depicted by a small square out there. Please change it. So the art of writing the small code depends on how we can map the planes of the solutions. So the problems plane is there and there's a solution plane. And what we're trying here to do is map that. The far away we move the solution plane up towards abstraction, we have a smaller set of the code. So this represents the grain of the solution. As we move up from the problem plane to the abstraction plane, we will have a smaller set of solution code, because as we move up, the grain of the solution will rise, and that will help us to address larger amount of problem that can be handled. So when we are doing writing the codes at a very lower level, that is very close to the problem space, we use assembly code. So here whoever has done MAH00140 would understand that how much it takes to just write a small code of trying to figure out or add something and do something out there. So the next level as we move up the plane is codes like the C or Java or whatever, which actually moves up the plane a little bit higher in abstraction, and we have a smaller set of code to do the same stuff that we are doing right now. And as we move up even further, we will be having scripts that solves the problem. It will like assemble the solutions into a coherent one, which helps us to solve the problem space. Now, if you see the next part is dividing the problem space into proper segments. Now, it is this part which is very important in order to achieve the ultimate objective of writing the small code. How do you partition it? Because this partitioning will, and the implementation of solution of these partitions will help us to get a code which is small and crisp. So now this figure actually shows us the various abstraction, how it is done. So if we have partition in a manner in which the various abstraction layers are non-overlapping, one is at a higher and the other is at a lower, we end up non-reusability and ultimately reach out in a situation where we have to have large number of fragmented codes. Now if you go back, you will see that if you can somehow reduce if you can somehow do something which brings the partitions in such a manner that it can be overlapped, and in a way that we have a reusability across these partitions, and then we can have a mechanism in order to reuse the components, one to leverage one from the other. Now these solution things obviously will not be at the same level. One can be higher, one can be lower. Only thing what we are trying to achieve is partitioning the problem in a way that we have a coherent solution thing, at least for larger set of these problem partitions. Now here you see Ollie Bates' famous 256 byte code, which was the smallest code written by this gentleman to run a Tetris program in a DVC. Now this is a very small code, that's fine. But are we really looking at writing small codes like this? Obviously not, because we will not be able to understand a bit of it once we move on in time. Now let's see how things mature with time. So you can see that in 70s we had the structured program which graduated into an object-oriented, then into the internet, then into distributed meta languages using reflection, and further moving into things that Google is trying to do with Dart. And now we have something called X, which is supposed to solve a lot of problems, as it can generate multiple code bases, but write a program in one single language. Now obviously these will all go through changes, and if you see that all what each of these are trying to do is trying to move up the solution plane slowly up higher into towards the abstraction layer, into the script layer, and even aggregate into that. So this actually is the natural history that has happened. Now let us look at what happens in the problem space. So the problem space is itself expanding. The amount of functionality that is getting, that is being expected of these applications and programs are quite large. And when it happens, the problem space expands, then how can we address this through the same models that we have seen just now? Now we have triangles which are closer to the problem plane, exposing web services which can be used to the clouds, and aggregated into solution space which addresses much farther, higher up where the user interaction is. This actually represents the cloud as a solution. Now moving further, you have the mobile. We have heard a lot about the mobile in this entire session that we've seen. And here is it, that it accumulates all the various advantages of the mobile. You have the gyrometer in the mobile, the magnetometer, and all the various devices in the mobile, which is actually interacting with the problem space very close to the mobile, so where you are located. And you can also interface with the web services and the mobile services, which can use the cloud to talk back to the various services which are there in the hosted and in the cloud. So this represents the solution architecture that is going to happen in this future. It's already started. Only thing it's going to be much more prevalent and much more deep. We have heard of HTML5 in a lot of sessions that we've heard. And so here's this HTML5 which is trying to solve all the problems, most of the problems, and address all the, bringing every platform into the uniqueness so that this can be provided as a solution across the various platforms and both the mobile and the web, and so it's an integrated platform system. So the coders will have to probably lesson coding, and testers will have to do a much more lesser testing of the solutions that are being built. Now, this is a quick survey that we have done, and here is a stopwatch program. So Windows C++ required about 120 lines of code to write. A Java AWT 42, a Windows 7 25, and HTML5 and JavaScript require 20 lines. So that you can see the user experience is rising, and you can see how the abstraction is playing into itself and rendering a smaller code as we move along. So the art of writing the small code would need better design. But this is where the difficulty or the complexity will rise. So you want to do a better dissemination of the problem space into smaller components, and in order to understand the good and have a good knowledge of that, in order to come up with frameworks, use the frameworks, and have a solution. And to end this session, this is a famous quote from Churchill. He was sorry to write a long letter because he didn't have time. So in order to write a small code, you will need a lot of time and hard work behind it. Thank you.